Good afternoon. My name is Shola Daniel Obanjesu from the Department of Microbiology, an OAU student. So, I'm here to solve the lab 5 and 6 questions given to me. So, I'll start with the lab 5 question, which is question 334 as it was given to me. Now, they said write a function to generate resistance profile summary. That's the question. So the app I will be using here is PyDroid 3, which I will use to run my codes. As you can see, I've already done this here, which is for the resistance profile summary as well. So this code is the code to generate the summary of drugs that are resistant, intermediate, and susceptible. So as it is given. Now this is resistance. This is the code to find the resistant ones, the number of resistant drugs, intermediate drugs, and susceptible drugs. So as I have written, we go further to the codes and then print. Print is like the last thing to do, but after that I decided to put a sample data which starts from the line 27. Can you see as I've clicked it here from the line 27? These are the sample data: amoxicillin, ciprofloxacin, fluoxacin, gentamicin, tetracycline, ceftriaxone. So those are the drugs I used, which are antibiotics. So we'll run the code now to make sure it is valid and has no errors. Now this is the output of the code: resistance profile summary for sample 1. Total antibiotic tested is 5, as I have said earlier. Now the resistant ones are 2, the intermediate ones are 1, the susceptible ones are 2. So the resistant drugs here are amoxicillin, tetracycline. The susceptible ones are ciprofloxacin, ceftriaxone. So the intermediate will be the last one, which is gentamicin. That's the intermediate. So you can see the program is run successfully. So program finished. So in a nutshell, let me quickly go to the second question. The second question, which is question 135. So the solution to the question. Now the question says add a method to petri dish that simulates colony expansion over time. Now the aim is to use the code to determine the rate at which the colony grows or increases in size. You understand? The colony does increase in size and growth rate over time. So the program to run that is what we are given here to do now, and this is the program right now. This is the program here. So the time step and the step which it takes for it to grow. Now you can see we started with import random, then the colony. We have not known the data to put here yet, that's why we put import random and stuff like that. But now this side is supposed to be the last one, which is the print, but we don't know what to input there, so I input the example. So from line 28, say, do you understand the line 28? Now look at line 29. As you can see here, we have E. coli, which is Escherichia coli, and the S. aureus, which is Staphylococcus aureus. So as it is in microbiology, so we used both examples. Now we'll run the code. Now let us run the code and see if it is valid or not. You can see the code is valid and it runs. So you can see time, step 1, step 2, step 3, step 4, step 5. You can notice the increase in growth and increase in size here. Right now, this Escherichia coli started from 10, it grew to 10.46, then later at the last step, which is step 5, it grew to 11.44. And as for S, which is Staphylococcus aureus, grew to 8.21, and from 8.21 to 9.21, that's a 1.0 increase, if you can notice that. So that's it.